Right, let's get started. We're going to open with an announcement from Dawn over here, who is with the Society of Women Engineers, which is not just for women.
Thank you. Yes, he's absolutely right. We are holding an event next week. It is actually exactly a week from now. It is Monday night, the 24th from 7 to 9. It is called Evening with Industry. This is when we get to sit down with a bunch of companies in the area, and we get to meet with them, get to talk about internship and job opportunities, get to network, learn a little bit more about the company. And this is open to everyone. So even if you aren't necessarily an engineer or in computer science, but you do have coding experience, you do have other skills if you're in physics or mathematics, please join. Professor Gentry will be uploading a link that will allow you to sign up. Please do. This is a fantastic way. Even if you're just a freshman, this is a great way to get started early. This is a fantastic opportunity. Highly recommend it. We have a lot of companies coming. We have Northrop Grumman, IM Flash, BioFire, which is over in Research Park. Great way to look for internships, especially over the summer. So if you have any questions, if not, then our information will be posted in flyer that he will put up, and please give us a holler, and hope to see you all there.
Thank you. Okay, so grades are starting to appear. The first two assignments, the first two problem sets have been graded. PS3 will be next. If you have issues with the grading, questions about the grading, do not post a note to Canvas. We don't see them. We don't go looking for them. We look on Piazza. So if you have a question about your grade, you can reach, you should know that you'll be able to tell who graded it. Message them on Piazza. Okay? If you've left a note behind on Canvas, message Piazza. So PS4 is out and due Thursday. As the semester rolls along, the Zybook assignments roll along, so I've been trying to keep them graded shortly after they're due in order to remind you when you see grades appear that there are Zybook assignments. So be sure to keep up with that. They're not as valuable if you wait a week to do them. It doesn't help your grade, and you don't get the full value of them as you look at them in a timely fashion. I checked right before class. I counted that 10% of the class has an average right now below 70. That's 35 people. 2 people currently have appointments to meet with a TA to get some one-on-one help. Those 2 students currently have A+ averages. So the folks that need help aren't getting it. The TAs are, a lot of the time in the CADE lab, you can see the schedule we have. This is the drop-in schedule where you can go get help on assignments. Monday, Tuesday, Wednesday, Thursday. Tons of time. A lot of times they're twiddling their thumbs. You can get a lot of attention if you go to the CADE lab. And this is the drop-in schedule as it currently exists. You can make 30-minute one-to-one appointments with TAs during those times. All you have to do is go right here and click on calendar. No, I don't want to go to calendar right now. And you can make an appointment. And this table shows you who you'll be meeting with and where you'll meet them. So I really encourage you to take advantage of this. Right. So any questions about these procedural matters, or about anything really? Any questions I could answer about the assignment or class, or how to get help?
Assignment 4, half done.
Hmm?
Assignment 4, do the whole thing.
Ah, yes. You need to note that assignment 4 has 2 parts. There's 5 methods you implement, similar to PS2 and PS3, and then there's a second part, separate part, where you're creating an animation. Be sure to do both parts. Don't just do one and think you're done. There are 2 parts. Don't wait till Thursday to start. Okay? Yes?
So could you like kind of go to the process of signing up for a one-on-one appointment? Because I've tried it before and I just kind of got confused.
The only reason I hesitate is that if I go do that right now, you'll be able to see who has appointments.
After
And
class.
given what I just said, I don't want to reveal people's grades. But fundamentally, you click on courses on calendar right here, and you'll see a calendar of things that are due. You'll see a big calendar with assignments and in all your classes, and mixed in with them will be these appointment slots. And it'll show whether it's occupied or not, and you just click on it.
Can you do student view?
That's a good point. Stefan just suggested I use student view, so let's do that. Okay, so here's a student view. I just clicked on calendar. And
Agenda.
this looks different from what I see. Well, that's agenda.
That's not their view.
Good thing you asked. I'm asking find appointment, and I do this. There we go. So what I did was I was first in the agenda. I think before that I was at the week. And from the week view, you see the appointments right here as well. And you can presumably click on and add yourself to the appointment. So a couple ways to do it. Thanks for asking. Any other questions?
Joe, can you do that again? I forgot to put it online.
Okay. So if you go into the calendar and click on the week view, you'll see the appointments laid out down here. If you go to, the other thing I did was I went to the agenda. Well, I think we're getting a bad take here because the main thing I did that caused these to start showing up, there was a place where I could ask it to show appointments. And I've already clicked it, so now it's showing appointments. So when you go to one of these pages, look for something that says show appointments, and it'll start showing the appointments. All right, now one of the things that you'll be doing on the next assignment is creating an animation. So I just wanted to talk about that a little bit because we often get a lot of questions on it. So, okay, so this is a sample animation that I included with the assignment. And most of this, this window and the buttons and the timer up here, all that stuff is given to you. Fundamentally, what you have to do is implement a method that takes as its parameter the current time in milliseconds since the animation started. And what it has to do is draw what the animation should look like at that point in time. So your method is called 30 times a second. And so the number of milliseconds will go up by about 33 each time. And based on that number, you decide where things are and draw. So here's what mine looks like. So I made mine physics-based to decide how the balls move, but you don't have to use physics to do it. You just have to draw something different each time. Okay? I said in the assignment that mine was mildly amusing, and I guess I got a sort of a mild reaction. I had thought about maybe having little stick figures running away in terror or having debris fly out of a crater. I didn't. So I don't expect you to take this one and change the colors of the balls and call it your animation. I expect you to do something different, and there's sort of some minimum expectations in there. But let me just show you. Oh, the other thing is, Stefan added this in, you can run the thing in reverse too. And it's no big trick because it's just asking you, what should I draw at this point in time? It really doesn't matter if it's running backwards. All right, so this is the animation.java is what you're writing. And right down here is the method, paint frame. So you get a graphics 2D object, that's G, that's the thing you draw on. You get the current time in milliseconds since the animation started. And you use that to control the position of things in the animation. And then you get the height and the width of the screen, the current height and width of the window. And you can see what I do is I draw 1, 2, 3, 4, 5. I draw all 5 balls. And then I do a little bit of physics. I figure out the current angle at which things are being fired. And depending on where I am in time, I draw the cannon, such as it is, and I draw the title. Or I might draw a cannon with a different title, or I might draw the crater. But it's based on, you can see, it's based on when enough time has passed. I do one thing. If another amount of time has passed, I do another thing. So there's conditionals that look at the current time and do things differently. Now, this says that I'm drawing 5 balls. Why don't I see all 5 balls at the same time? Yeah?
Because you're passing in the time, and then it only draws if the ball is there at that time, inside of that.
Okay, he said I'm passing in the time, I'm only drawing the ball at certain times. Actually, I cheated a little bit. That's essentially right. Notice this ball, the first ball, the green ball, I give at the correct time. The red ball, I lie. I subtract something off the time, so the time is negative. And the blue ball gets an even more negative time. Interval is the time between when things are fired. And then the way the method draw ball is written, it doesn't do anything if time is negative. So that's just a little hack I put in to avoid drawing the ball until it was time for it to draw. The basic idea is you need to do a little bit of math on the time. Like what if you wanted to have something that moves smoothly from left to right? Now you can draw things at x and y, x, y coordinates on the screen. What would it take to move something smoothly to the right at a constant rate? How would you calculate the horizontal coordinate? Any ideas? Yeah?
Multiply the velocity by time.
Okay, so basically he said pick a velocity, multiply it by time, right? Then as time gets bigger, it moves to the right. And we'll see if we can quickly do that. I'm going to come up here to my to my paint frame method, and I'll just put in G dot, so I can say, let's say, fill I think it's fill rectangle. Okay, fill rectangle, give the x and y coordinate and the width and the height of the rectangle. So let's, x is the left to right, so I'll leave that. I'll give 200 to this, and then I'll make the rectangle be 30 by 30. And then I will just make the x coordinate be
Time.
4 times time.
4 times.
Okay, yeah, you're right. Problem is 1 second, it's 1,000. And these units are in pixels, and so it needs to be time divided by something, or it'll just zip out of the way. So I'll divide it by 100. We'll see what happens. Okay, so all I'm doing is every time the frame is called, it's going to draw the rectangle in a slightly different position. Yes?
What project is this? Because I do not see it on today's lecture.
It's PS4 starting point.
Oh, PS4.
Yep. So let's run this and see if I've succeeded. Okay, there's our rectangle. It's all the way to the left. It's 200 pixels down, all the way to the left. 0, 0 is one of its corners. I don't remember which corner it is.
Top left.
Top left is 0 is the origin. And then as I play, it's going to, being called, time will increase, and therefore since the horizontal position is based on time, it'll move to the right, slowly. Okay? What do I do if I want to make it move faster? I'll divide by 10 instead of 100. It scoots along. What if I want the box to be what if I want to be red after 1 second? Well, let's just make it red. All right, it turns out that's, you saw some of this in the lab before, so I'm going to tell the graphics object to draw using red. I changed the color to red before I draw the rectangle. And now it's red. Now, what if I want the rectangle to get slightly bigger as time goes by? There's the square. I want the square to get bigger as it moves. Yeah?
Change the last two parameters.
Right. Instead of making it 30 by 30, I'll make it plus time divided by 100. So the size of the rectangle will change. So let's try that out. Yeah. As it moves, it gets bigger. Right? What if I want to make it stop after 2 seconds? I want it to do its thing, but after 2 seconds have passed, I just want it to stay where it is. Now, let's maybe change that. I want it to disappear after 2 seconds. Yeah? He said put a while loop. Turns out, you don't need to write any while loops. The while loop is in a different place. The while loop is what's calling your method over and over again. We need an if. So we just say if time is less than 2,000, our units are milliseconds, do this. So it'll draw it for after 2,000 milliseconds have passed, 2 seconds, it'll stop drawing the rectangle. So. Okay. What if we wanted to start moving down after 2 seconds instead of disappearing? Yeah?
Add an else.
Sure. Else, we're going to do this, except we're not going to be changing the x coordinate anymore. So after 2 seconds, where should it be? Time after 2 seconds, time will be 2,000, so the x coordinate will be 200. So I'm just going to hard code that 200. And then we'll start moving it down. Let's just say plus time divided by 10. Is that what I had before?
100.
Let's see.
You can go slow. Okay.
Ah. Now why did it jump? Why did it start moving where it was? Yeah?
Because time is already further. Time divided by 10 is already 200.
Right. By the time we got to here, time had already reached 200. So really what I want to do is time minus 2,000. I take away the, I don't care about the first 2 seconds that it passed. I want to control by the time past 2 seconds. Okay? So it's really easy to, play. I wouldn't recommend that you start with, a finished idea of what it should be like and try to write it from scratch. What I suggest is that you, get some idea and just start experimenting with what you can do. Because, just write a little bit of code and like I did right here. It's not that hard. I'll do one last thing. What if we wanted to change color every half a second? Let's say switch from red to blue every half second. I mean, what we need to do, if depending on something, we need to set the color to red. So sometimes we'll set the color to red, and sometimes we'll set the color to blue. We want to switch every 500 milliseconds. Yeah?
Time modulus 500
Okay.
equals
So
0.
close. I think we want to do, not modulus. I want to do time divided by 500. Okay, so time divided by 500 is going to be 0 when we're less than 500, then it'll become 1 when we're less than 1,000, then it'll become 2 when we're between 1,500 and 1,000. So we're getting 0, 1, 2, 3. So what can we do with that? Yeah?
Modulus by 2.
Right. Then we can take that number. That's when we do the mod, and we'll find out if it's even. So if the modulus of time divided by 500 is even, we'll color it red, others will color it blue.
Okay, get rid of that red down there.
Oh yeah. You got to make sure we get rid of that. I'll clean this up a little bit. And then we'll go boom. There it's red. Okay. So it's it's just doing its thing. You don't have to write any loops, just conditionals. Yeah.
Where's the event where I'm not really understanding where the second if else loop happens, or
Well, so the question is, when does all this happen?
or like
Um,
you made the event changed. It changed from going across the screen to going down,
mhm.
and now I'm not sure what parts of the code tell it to do that.
Okay, well, this method, paint frame, is called 33 times a second. Each time it's called, the time parameter is bigger. This first conditional, it just looks at the time and it does some math and figures out whether to color red and blue. So after it's set to red and blue, it looks at the time, and depending on what it is, it positions the rectangle in the right spot on the screen. And then it goes on and does the rest of my animation down here. And it does that 33 times a second. You don't have to worry about that, you just have to be ready to be called. So I put this print line in here, print out the time. So what should appear on the console when I run this? There's the console. There's the animation. You can see it's just being called over and over again.
Also, it stops going across after a while.
Okay?
Can you leave that code up there for a minute?
Well, just for a minute, but you can see it later after class. So, also, this method, paint frame, is supposed to return false. It's supposed to return true when the animation is over. So mine is just coded to stop after that long. Yeah?
What's the program using as a clock? Where is it getting the time from?
Let's see, it's probably, it's using a timer. So there's basically a timer object that you can say you can set a timer to call a method every so often.
And then how does it keep track of that time? Where does it?
Well, I'd be happy to talk to you about that after class.
Oh.
So he's asking questions basically, how does the code that calls this method work? It's interesting, but it's not really necessary to understand it and do the assignment. Yeah?
So like, does Java just automatically use milliseconds as like the measurement for time, or did you like make a variable for time?
He's asking, is Java using milliseconds automatically? The timer that we're using times in milliseconds. So if you're doing timing for an animation, milliseconds are the right units. If you're trying to time how fast a computer program runs, milliseconds are too crude. You need to get down to nanoseconds or microseconds or something. But yeah, milliseconds are fine for human things. Okay? So don't distress too much over this. It's supposed to be fun. It's supposed to be a break from the grind of implementing 10 methods and satisfying J. You can express your creativity. You may say that you're not artistic. Well, I'm not artistic either. I can at least draw colored balls, right? And I didn't even try to draw a cannon. I just drew a lump on the ground. So.
Are you going to show last year's?
Well, I won't show last year's right now. If you look at the assignment, there's a link you can click on that'll show you our film festival from last year, so the animations that TAs like the best. And some of them are really impressive. By no means is that like the representative of the average, or even of the average that got 100%. These people went well beyond what we expect. And we'll do the same thing this year. We'll get the TA's favorite and show them in class someday. Okay? Any other question I can answer about that? Yeah?
I'm not sure why we can do use time divided by 500, and take the module 2 equals 0.
Okay.
And repeat that. Because if we write down something like that, does that mean only when time is like 1,000, 2,000,
No.
it can do that?
Okay, so you saw what happens. In fact, let's do it this way. I'm going to run it again. I'm going to print out the raw time that we got, and then I'm going to print out time divided by 500 mod 2. And let's see what it looks like. Okay, so if we go back up to the top, you see at time 0, the result of that operation was 0. At time 36, 0. It was all zeros until we hit 500 milliseconds. Then it switched over to 1. And then it stays 1 until we get to 1,000. It switches back to 0. Let's take this for example. What's 973 divided by 500? Who could tell me? What's 973 divided by 500? It's 1. It's integer division. It's 1 with a remainder we don't care about. And then when we take 1 mod 2, it's 1. And so it's odd, and so we use blue. Yeah?
So you said that you'd be able to see your code later. Where is it going to be for what you've done to PS4 for us to be able to look at it?
Okay. I will include this with the lecture project that I post every time. It'll also be on the video. Yeah?
Are we allowed to add extra functionality, like, for example, make your button or responding to mouse clicks and stuff like that?
How do you feel about that stuff?
I didn't hear it.
He wants to soup up the interface, adding extra buttons and such.
There was one in the examples that did that.
Okay, if you want to, this is the basic idea. If you want to go above and beyond and mess around with the interface, that's fine, but the play button has to do what the TA expects, right? Right. If the TA can't figure out how to run the animation, that's bad. So you can add extras, but make sure the basic stuff works.
I would suggest making 2 animations.
Yeah.
Make one the regular assignment, and then make an additional one for, and you can turn them both in and we can see both of them. Just put in the notes that you've turned 2 different ones in.
But I thought that only the final thing that you turned in was counted.
That's why I said put a note in there if he wants to make a special one.
Or you can put both versions in the same project.
Yeah, and that.
It's called something different. Yes? Did you ask that question on Piazza before class?
No, that was me.
Okay. So yeah, I was asked, the answer would be on Piazza after class. I need to think about the question, which was, is it okay if it doesn't quite work right in reverse? And I want to ponder that. The only way it won't work in reverse is if you use state variables that get set in one direction but not the other. And we haven't even talked about that yet. So it's only a problem for advanced students. So. Any other questions? Yes?
I'm not sure everybody's ever has asked this, but can we import images from outside of the program?
Yeah, you can import images. You can figure out how to use them. Yeah, you can use images. They'll need to move. Such. Okay, have fun with it. All right, next thing I want to talk about is a little bit about PS3, which you just did. So, let me find where I need to be. All right, so this is a piece of the method library. This method here, got some questions about it. It's supposed to take 2 strings and tell you whether or not they consist of the same tokens, same number of tokens, and those tokens are identical. And so to save myself some typing, first thing I did was I created scanners from the 2 strings. Because if I got to tokenize the strings, it's easier to let the scanner do it for me. And then what I've written in here is the basic, just the enumeration version of the loop that consumes the scanner. Paste it from somewhere else. And so what I got to do is turn this into, first I'm going to do it using an accumulation loop. I want an accumulation loop that can tell me, determines whether or not the two scanners contain the same tokens in the same order, the same number, and everything else. So if I'm turning it into an accumulation loop, what do I need to do? What do you have to add to an enumeration loop to have an accumulation loop? Yeah? An accumulation variable. And it should be the same type. It'll be a Boolean. That's what we're returning. So I'll just make it Boolean is same. And we'll initially, before we've seen anything, yeah, it's the same so far. We may change our mind later. What else do we have to do to turn this into an accumulation loop? Besides adding an accumulation variable, yeah?
Have an index.
We don't need an index. 3 things we have to add, yeah?
A return statement inside the loop.
Well, you're thinking of a searching loop.
Oh.
I'm going to write it as an accumulation loop, then we'll write it as a searching loop. Okay? What's the last bit of a searching loop? Yeah? Well, there's going to be a statement inside the loop, but what goes outside the loop? What do you add after the loop? Yeah? Right, we return the value, we return the accumulation value like that. Okay. And now we have to figure out a couple things. We've got to control the loop somehow, and we've got to do something inside the loop to compare tokens. Well, clearly we need to, this might be a little perplexing because do we do while scan 1 is next, or do we do while scan 2 is next? Or both? The idea behind the loop is each time through the loop we're going to grab the next token from each scanner, compare them, and use the result of the comparison to update the accumulation variable. So the loop had better stop as soon as one scanner runs out of stuff. Or we're going to have trouble, right? We need to be able to get a token from both scanners. So what we have to do is, this is the twist that I mentioned.
Wait a second, wasn't this a method on PS3?
Yeah. So I'm writing it that way. While both scanners have tokens left. Okay? All right. Then in here, we need to update the variable. It's always of the form something like is same equals is same. And somehow we have to combine it with something. So how do we update the accumulation variable here? Keeping it true if it's already true, or making it false if it needs to become false. Yeah? Okay, so we need to, let's try this first of all. What if we do this?
Dot equals that thing. Oh, that one.
Okay, what do you make of that? We say is same. Basically, we compare the next token in scan 1 to the next token in scan 2. That's either true or false. We store the result in is same. Discuss. What do you think of that? Yeah?
If, let's say, the middle one, like one token in the middle doesn't match, if the next one does, that will change it back to true.
Okay, so I'm going to paraphrase what he said. The value, written this way, the value of is same is going to be the result of comparing the last pair of tokens. Maybe there are 100 pairs of tokens. Every single one of them was different, except the last one happened to be identical. The last pair is identical. So go through the loop. Is same gets false, and it gets false, and it gets false, and it gets false, and it gets false. And finally, at the end, it gets true. And the loop ends, and is same is true. What do we need to do? Yeah?
We could add in the while loop, we could add in an if statement saying if is same.
Okay. So he's saying we say if scan1.next equals scan2.next. Well, I want to avoid writing an if. Back there, yeah.
What if you added in that while loop conditional, you added and is same?
Okay. So, you know, when you're accumulating integers, adding a bunch of integers, you say accumulation variable equals accumulation variable plus new value. So we're going to say is same, and that. So if is same is true, once is same becomes false, it'll stay false, right? Right? Once is same becomes false because you found a mismatched pair of tokens, then no matter what the value of this is false and whatever this is will still be false. So it'll be, you know, it'll stay, once it becomes false, it stays false. Are we done? What's left? Yeah?
You need to put an if for if they have different number of tokens.
Okay, when the loop ends, all you know is that one of the scanners ran out of tokens. If the other scanner still has tokens, we've got to return false. And he said to put an if. But I'm a member of the Association for the Prevention of Cruelty to If Statements. Just because you're computing a Boolean doesn't mean you need an if. Do Boolean algebra. So what we return is, we'll return is same, but we also got to make sure that the two scanners are the same length. How do we do that? Yeah? Well, scan1.hasNext, that could be false. So if we did this, okay, that's attempting to do that, but what? Now she's suggesting we do some negating, but let me just point out that suppose both scanners are the same length, the loop ended, and now they're both empty. All the tokens were the same, they were the same length. We want to return true, but what's this going to be? False.
Yeah, that's a...
Put a different operator there. Yes. And just to make sure of the grouping, I'm going to do it this way. So we return true if is same is true, and if scan1 and scan2 are both empty. We know one of them is empty, so if the hasNext values are the same, that means they're both empty. Right? No if statements needed. Now, you may not have written it that way. That's understandable, but I just wanted to take you through my thought processes. Now, I'm about to mess this thing up to make some points. Before I do that, any questions about the correct solution here before I make it incorrect? Okay, mistake number one. Comparing strings with double equals. Don't do it. Okay? If you read Piazza et al., you know not to do it, because I get asked this question several times a week. Here's the deal. When you're comparing objects, double equals, the question you're asking with double equals is, are the two objects physically the same object in memory? So remember, a variable holds a reference to an object. So I have a variable here, and I may have, this may reference a string hello, and this one may reference a different string hello, different place in memory. We would think of them as the same string, but if you ask whether these two strings are double equals to each other, the answer is no, because the two strings are stored at different places in memory. What you want to compare the strings with is the equals method. That tells you, that they look the same. Okay? So universally, double equals always is asking for, when you're talking about objects, are they physically the same object in memory? Some classes will give you an equals method that does something more like you probably want to have done. But for strings, I don't know if ever in my life I've wanted to do double equals on strings. Okay? That's just not an interesting question. Or is it physically the same string? Let me show you another thing. So in my stub, I had return false. And so I've seen this. What's wrong with that? It's printing out the right answer, and then it's returning false. Yeah? Right. He said it returned false no matter what. This will fail all the tests because it always returns false. Or I guess it'll fail half the tests. The ones that are true is supposed to be returned. Yes, it prints out the right answer, but why is a method that prints out something really not as useful as a method that returns that something? Yeah?
Because we're going to be calling the method in a bigger...
Right. We want to be able to call the method and use the result it calculates in a different context. And if it's printed out to the console, we can't get at it. So yeah, you don't want to, printing out is not the same as returning. Okay, so those are a couple common mistakes that I see. Now, what would it take? We could write this also as a searching loop instead of accumulation loop. It's actually more natural as a searching loop. What are we searching for? So we're going through these searching, yeah. Right, we're searching for a pair of tokens that don't match. Yes. So let's come down here and try it again. I'll call it same tokens 2. We won't use an accumulation variable. What do we do instead? Inside, we look at a pair of tokens. What do we do when we compare them? Yeah?
So you would return false if the tokens.
Right. That's exactly right. If scan1.next equals scan2.next, well, actually, if they don't equal, so I have the parentheses balanced I'm looking at here. We return false. As soon as we find a mismatching pair, we're done. We just return false. And what have I done here? I think I need another parenthesis. Control-Shift-F, re-indents. Right? Now, what if we fall through? What if we get out of the loop and we never return false? It's true as long as both scanners are empty. So if they're both empty, we return true, otherwise we return false. So that's the searching loop version of it. Now, I think the searching loop version is superior if you're talking about the efficiency of the method. Who could explain why would same tokens 2 tend to be faster than my original same tokens? Yeah?
If you were to have 2 strings like 100 long and the first token wasn't the same, with the accumulation one you'd have to get all 100.
Right. With the accumulation loop, you've always got to look at all pairs. With the searching version, as soon as you find a mismatched pair, you're done. And it could mismatch on the first. So the searching loops, the 2 loops take about the same amount of time if the scanners happen to be equivalent. But if they're different, the searching version is going to be faster. Now, faster is not something we usually worry about in 1410. That's something you worry about in 2420. But it's worth noting. Okay. So, any other questions I could answer about this? All right, I'm going to show you one more thing here, and we'll look at some new stuff. Here's the animation. This is some code that appears at the beginning of my class. So this isn't inside the method. It's just inside the class. Private final static double G equals, and so on. Got a whole bunch of these. Oh, by the way, don't hand in something that says that you're Joe Zachary. First thing you should do is your name here. It shows up in the window when you run it. Who knows what these are for? Okay?
Global variables that can be used in all methods in the class.
Okay, he said global variables that can be used in all methods in the class. I'll be a little bit more precise of exactly what these are. They're global constants. Okay? These are called static constants. And They can be used by any method in the class. And what makes them constant is that keyword final. Final means you can't change them in the program. So if you try to change the value of canon Y down below, it wouldn't compile. So they're constants. The only way to change them is to stop the program and edit them and then rerun the program. Why do I have them here? Yes?
So that if you were to want to change some aspect of, say, the cannon's height or its width, you could just change those single variables, and it would change every other instance of call of those variables. Okay. So what he said was, it makes it easy to make changes. So if I want to change the diameter of the ball, I don't have to go look at the code. Suppose that, let me just show you the code down here that does stuff. See, those things in all caps in dark blue are these static constants. And, you know, when I draw the ball, I have to take in the position of the cannon, the diameter of the ball, into account, figure out where to draw the ball. And I could just have numbers. I could have just, you know, instead of putting ball diam here, I could have put 20 here, and 20 there, and so on. The word for numbers that appear mysteriously in code like that they're called magic numbers. Magic numbers are considered bad because you see 20 in a formula, that doesn't tell you what it's for. You sort of have to read the code to figure out, oh, that's the diameter of the ball. But since I used constants, symbolic constants, if I want to, as long as I've written the code correctly, if I want to change the ball to have a diameter of 80, I just have to change it once right there. I don't have to go search for every 20 and change it to 80 and then find out, oh, there was 120 that I shouldn't have changed because that 20 was actually the size of a cannon or something, right? So I just have to change it once, and then when I run it, you know, it looks stupid, but it, you know, I guess it doesn't look stupid. Yeah. Now, you might say the hole should be bigger, so maybe I should have the hole depend on the size of the ball, which it doesn't. But if I had written the code so the hole depended on the size of the ball, then the hole would have gotten bigger right then when it crashed in. So this can make your life easier. Yes?
Is there any way in a graphics 2D object to, like, set which object is in front of which, or does it just based on, like, the sequence?
Okay, so he's looking at this blue ball and wondering, first of all, why is that blue ball drawn in front of the green and the red? It's just the order in which they were drawn to the screen. The green ball and the red ball were drawn before the blue, and so the blue showed up on top. And he's wondering, is there any way to control this other than the order of drawing? And, you know, I'm not sure. I've never done it any other way and control the order of drawing. Okay? All right, let's take a break, and then we'll look at some new stuff. All right, let's get started again. We're going to talk now about a new kind of object that we haven't encountered before, called arrays. And when you hear the word array, you should think fixed length list. So an array is just a fixed length list of things. Now, why would a computer program need to have lists of things? Think about programs that you use, apps that you use. Where do you see lists? Is that a common thing? Have lists, or is it an uncommon thing? Who could give me an example of a list in a program? Yeah?
People attending an event.
Say again?
The names of people attending an event.
The names of people attending an event. They've got to be kept in a list somewhere. Okay? What else? What about this? The home screen on the phone. Those apps, those icons are stored in a list somewhere. The program contains a list of icons. What about when you use Eclipse? You have a list of projects. Project contains a list of, source contains a list of packages and so on. So they happen all the time. Now, arrays are kind of limited in that they're fixed length. Lists usually grow and shrink, and we'll see, Thursday we talk about lists that grow and shrink, but we'll start with arrays. They're built directly into Java, so they're not part of the Java library. They weren't added at, the things in the Java library were just written in Java after Java existed. Arrays are fundamental part of Java, just like ints. Arrays, when you declare an array, you have to say what type of thing it's going to contain. So you don't have an array that contains, say, an int in one spot, and then a double, and then a string. It's got to be an array of strings, an array of ints, an array of doubles. And here's how to visualize it. This would be an array of ints. There are 5 ints in it, and they're indexed starting at 0. So if we ask what is in location 0 of the array, we would be told 32. If we ask what is in location at index 4 of the array, we're told 66. If we ask what is the length of the array, we'll be told 5. So it's indexed like a string is indexed, beginning at 0. And here's the syntax. So if you want to declare these are 2 examples of declaring a variable of an array type. So this first one is an array, the variable is called A. It's an array of strings. And the way you know that is you see a type name like string followed by empty square brackets. So the way you read that is array of strings. So A is an array of strings. B is an array of ints. Okay? So the type name for an array is a base type, the type of the thing it contains, followed by empty square brackets. If you want to create a new array, you use the new operator, just like we've used to create new scanners or whatever, new big integers. You say new, and then you give the base type, and then inside the square brackets you put the number of elements you want. So this will create a new string array that has 20 elements in it. This next thing here will create a new integer array that contains 25 elements. If you want to access at a given index, you do it like that. You say A sub 6. In square brackets, you put the index of the thing you want. So I want the thing at index 6. If you want to modify an array, you say A sub 5 gets hello. So you essentially use the assignment operator to store into the array at a given index. If you want to know its length, you say A.length. And it's kind of a weird thing. It's not a method. There are no parentheses. That takes some getting used to. It's just A.length. If you want your array to grow and shrink, you're out of luck. Best you can do, if you need a bigger array, is just make a bigger array and then copy the overlay over into it. But there are better things to use if you've got to grow and shrink. Okay, so that's the basics. And we're going to look at the basics in action in a second. Now, when you use arrays, you'll be writing typically loops. Just like you write a loop, the loops that consume arrays are a lot like the loops that consume strings. And for loops are pretty much designed for use with arrays or strings. So for loops are an alternative to while loops, and now's a good time to learn about them. And the way it works is, this says, okay, declare a new variable I and set it to 0, and then start a loop. Before the loop runs, see if this is true. If it's not true, the loop is over. If it is true, execute these statements, and then execute this thing here. I++ is a shorthand way of saying I equals I plus 1. Okay? After you do that, you do this test again. Execute the statements, increment, and so on. This is the equivalent while loop. We set I to 0. While the condition is true, execute the statements and do the increment. In fact, that's sort of an equivalent while loop. Now that I look at it, it's not. I can see a problem with it, but close enough. Why did I put the example while loop inside this pair of braces here? Yeah?
Because the int only exists there, I.
Right. This I right here is only usable inside the for loop. And so I put these scope markers in to say that this I is not visible outside of this section right here. So the advantage of a for loop is it's just more succinct. You may think it's cryptic. You may decide, I will never write a for loop because it's too cryptic. That's your right. But you'll be reading lots of for loops in your life if you do this. There's no avoiding them, so you might as well get comfortable. I'll talk about for each loops next time. So let's look at arrays in action. So I'm going to go bring up some code. All right, public static void main. What does main take as a parameter? Right, look right here. I've always glossed over this. Now I can explain it. Yeah?
An array of strings?
An array of strings. So when main is called, it is passed an array of strings. Now, there's a natural question that follows on from that. Where do the strings come from? Okay, and that's a fair question. Let's look at that. Let's see what this method does. First thing it does is it prints out the array of strings. So that method, we'll look at the method in a minute. That method will print, it'll take an array of strings, and I think it prints one element from the array on each line. So let's run this and see. Let's see what it prints out. Let's look at this mysterious array of strings. Well, there's other stuff it's doing. The array of strings should have been right there before the 5.0. And it's not. So evidently the array of strings was empty. There was an array of strings. In fact, we could nail it down. Let's do this. Let's print out args dot length and run it. There's the 0. So it was empty. What these args are called, what this array of strings is called, they're called command line parameters, or command line arguments. And it goes back to the day when programs were launched from a command shell. So here's a command shell. I have got it connected to the folder that contains the compiled version of the code. So there's the packages, arrays, CS1410 exceptions. We're dealing with arrays right now. So if I look at what's inside the arrays folder, there's arraydemo.class. So this is, you can get outside of Eclipse and run a Java program. You just say Java and you give the full name of the class, which is arrays.arraydemo. Package name, you got to be connected to the folder that contains the packages. And you just give the full name, and it runs. Prints out what it was printing out before. So you don't need Eclipse to run a Java program. If you do this, anything you put after the name of the class is a command line argument and will be passed in. So I can say 1, 2, 3, 4, 5. Okay? And they're made available to the program, and the program prints them out. Now, does this seem like a fundamental feature? Or is this just not very useful, just sort of old-fashioned? What do you think? Look at the screen up there. Do you see anywhere else command line parameters? Do you see another program up there that is taking command line parameters? Java. Java is a program, and it is receiving as command line parameters all this stuff. So Java, when Java runs, it gets the stuff that follows, when it's run from the command line, it gets all that stuff and uses it to do the right thing. If I want to see how many Java files there are, in, let's say I want to dir, if I do dir, I see that. Let's say I want to see everything that has an E in it. Okay? That star E star was a command line parameter to dir. If you write scripts, scripts are programs that call other programs. Your script will pass command line parameters to other programs. So they're very important. Okay? The question though becomes, how do you, what if you're inside Eclipse? How do you do command line parameters? Let me show you. If you come here to run, and I'm coming down here to run configurations. So run configuration is a way to run a program. And there are run configurations for every main method I've ever created that exists in my workspace. So right now I'm at array demo. So array demo's run configuration, there's a tab right here that says arguments. So if I go there and I say, this is a test, then those parameters will be used when I run the program. So I've just run the program again. This is a test was passed in. So you can experiment with command line parameters from inside of Eclipse. Okay, so let's look, here's a method print array that we're using. Let's see how that works. Okay, so print array is right there. So print array doesn't return anything. What does it take as a parameter? A string array. Now when we called it the first time, the string array that we're passing it was actually args. So we're passing it the array of command line parameters. And it just uses a while loop. We could have written a for loop that just loops through the array. This is very common. You start at 0, and then while I is less than the length of the array, you do something. And we just print out strings sub I. So what we do is we print out strings sub 0, then strings sub 1, then strings sub 2, and so on, until we print them all out. Okay? A lot like, it's virtually identical to what the code would look like if you printed the characters in a string, for example. Okay? Oh, let me stop here. Not stop, let me pause here. That's your first look at a method that implements an array. So you notice that you've got to declare that it's a parameter. You declare it using the syntax for Java arrays. Then you access the elements using this subset, that index notation, and you've got that dot link thing. Okay. Any questions I could answer about that?
For the array index for the array for the arguments, does that have to be a string in the name class?
Okay, so we asked, Does this have to be declared as a string array? Yes. If I made it an int array, my goodness, there's an error right there. Wow. Yeah, as far as I know, it has to be a string array. I expected it to have an error right there, but I'm a little confused. Yeah, it should be a string array. Anything else? Let me show you another place where Java arrays show up. This method right here, average, takes a variable number of parameters. So I can pass it the numbers 1 through 9, it gives their average, but I can add as many parameters as I want, as long as they're all ints. So given what you know at this point, you may wonder how that works. Let's go look and see how average is defined. So what you see is that average takes 2 parameters. It takes a double. Then the second parameter is that weird syntax. A double dot dot dot. Okay? What that means is there has to be at least one double when you call it, and then there can be any number more. But whatever the extra parameters are gathered up into an array and stored in rest. So effectively, rest is an array. Okay? Now, you might say, why didn't I just say this? And the difference is, if you declare it that way, then there has to be 2 parameters, a double and a double array. And that's not what we want. We want to be able to we don't want to have to build an array. So that's sort of an automatic way of making an array out of the rest of the parameters. So just think of rest now as being an array of doubles, and look what we do here. I'm supposed to add them up and return their average. So I just write an accumulation loop. I set total to first. Then I loop through all the elements in the array and add in. I say total plus equal rest sub I. That is shorthand for total equals total plus rest sub I. So that's the same thing as this. Just a quicker way of writing the same thing. So that just goes and adds up all the numbers in the array. It gets first, and then rest is effectively an array. So it just loops through the array and adds up all the elements. For comparison, here's a while loop. It does something. And then we compute the average down here. That's another example of arrays in action. Yeah?
Does that little dot 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 work for any kind of data type, or is it just doubles?
No, you could. You say int dot dot dot, string dot dot dot, whatever. It's just a way of saying 0 or more of these things. And also it arranges to combine them into an array called rest, whatever you call it. Anything else?
I have lots of questions, I just don't know what they are.
What's your question?
I have lots of them. I have lots of questions, but I'm just not sure what they all are.
Okay. All right. So.
I know.
Okay.
Why would using an array instead of a dot 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 require you to use 2 doubles in that case? What would the second double help?
Let's go look. Let's see I change this to, say, double. What I want you to notice is the compiler does not complain at all about the average itself, right? Either way, it's viewing rest as an array of doubles. So it doesn't make any difference to the code here, but it does make difference up here. Okay, and the error message says the method average, which takes double and an array of doubles, is not applicable to the arguments int. So it wants to see exactly 2. So to use average this way, I would have to build an array that contained the numbers 2 through 12, and then pass that array as a second parameter. So the dot 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 just makes it easier to call.
Why would it only take 2? Why does it decide with the array that's now going to take 2 parameters?
Well, look what we said here. We're saying it takes 2 parameters.
Oh, those
right? A double and an array of doubles. So we got no choice. Let me go back. So I'm trying to show you ways in which arrays appear naturally in a Java program.
I see. I assumed one was first.
Okay, you need to raise your hand and wait for me to call on you before you ask a question. And sometimes I don't call because I got to do other things. Okay. Let's look at, this is a method that creates an array. Okay? It creates an array and fills it with randomly chosen integers. So it takes as a parameter the size, the desired size of the array. Look at this statement right there. That's where the empty array, not the empty array, the unfilled array is created. So we're saying, there's a lot going on here. What's the purpose of this right there? Yes? Okay, we're declaring a variable, random array. We're saying random array is an array of ints. Now, what if I left off the square brackets? You'd be saying random array is an int. It's not. It's an array of ints. So we got to do that. And then we are initializing it. What are we initializing it with? Yeah? Well, yeah, we're using n here. What does this create? Go ahead.
A new array object with type int with n elements.
Right, it creates a new array of ints that contain n elements. Now, n had better not be negative or you'll get an exception here. So what we're doing is we're creating an array, storing it in this variable. Then we're looping through all the indices of I, all the valid indices, for int I equals 0, I less than n, I plus plus. And then into random array sub I, we store. I just create a random, I don't know if we've looked at this kind of object before. It's a random number generator. So right here I created a new random number generator. And down here I'm asking for a random int between 0 and 999 inclusive. So I get at most a 3-digit integer and I store it into the array. And then when all done, I return the array. So that's a loop that is initializing an array. Okay? Well, let's look at what else there is. We make the array. Here's a method. So there's a class called arrays. You have to import it. It has a method called sort. You pass in an array of integers, it rearranges the array so they're in ascending order. So when I run this program, you can see this was a random array until it was sorted. So now you see it's in ascending order. So it's nice to know, that class has methods that'll help you with arrays. Finally, here's a method that you give it a folder, name of a folder, and it displays everything the folder contains. So you've seen that happening. Every time I run this, at the end it displays everything that folder contains. Let's see how that works. Here's the method. So there is another class that we've never used before called file. So we can create a new file. This is the path to a folder. We create a new file out of that string. And now we have a variable called folder that contains that. Then we call the method list files on the folder. What does it return? What does list files return? Yeah?
The list of files.
Okay, it returns an array of files. You can tell right there, an array of files. It's just the files that happen to be in that particular folder. Okay? So next time we'll see things that are more powerful than arrays that can grow or shrink, and you might think, well, I'll never use an array. But if you want to list the files in a folder, you're going to get an array. This is, we'll skip that. I'll look at that next time. Here's a for loop that just prints out all the files. Again, we just loop through. So contents is the name of the file array. So we just, for I equals 0, I less than contents.length, I plus plus, you get to where you can write that in your sleep. We grab the file out, contents of I is a file, we pull it out and we print it. And that's what you're seeing printed out when the program runs. Yeah?
I'm having a lot of confusion with this program. So, for example, in the public static void main, I see a lot of methods being called that don't actually appear in array demo, like toString.
This here?
So where are those?
Well, it's arrays.toString. So toString is in the arrays class. And up here we see we're importing java.util.arrays. So that's where that one is.
Oh.
So all the methods we call are displayed somewhere or defined somewhere. That, you know, that one's displayed there, and so yeah.
What's the deal with that for loop in the display folder contents method? What's the deal with that for loop? I haven't seen a for loop that looks like that.
Yeah. Well, okay. I said I would talk about it last time, but I'll just do it right now. That's called a for each loop, and what that says is for every file in this array, do that thing. So it takes care of figuring out, of giving you know, every element in the array one at a time. So you don't have to say, you don't have to generate any indexes. You just say, give me, iterate through all the files. So it's sort of a much shorter way of writing it. Okay? Yeah?
So what's file?
What's file?
Yeah.
It's a file is a class. File objects represent files on your computer. Just like, you know, random is a new class we've never seen before. It's a random number generator. So what you find is as you program, you learn and use about, and use more and more of the classes in the library. Okay, we'll end there. If you have any other questions, come and ask.